Hi everyone and welcome to Smart Alex Mathematics. My name is June and I'm a mathematics tutor. Over the past term, I've been working with my Year 9 students on index laws. Whilst most of them were quite comfortable applying the basic index laws, where they needed a bit more help were questions involving a combination of index laws. So what I would like to do in this video is to work through some examples so you too can also have a better understanding of how to approach these types of questions. So let's get started. First, we're going to review all the basic index laws. The first index law is multiplication. When we multiply two terms together and they have the same basis, then we can add the indices together. For example, 5 cubed times 5 squared would be equal to 5 to the power of 3 plus 2, or 5 to the power of 5. For division, we only need to subtract the indices. An example would be 5 cubed divided by 5 squared. This is equal to 5 to the power of 3 minus 2, or 5 to the power of 1, which is also equal to 5. Power of a power. This is when we raise a power to another power, and what we do is we simply multiply the indices together. An example is 5 cubed squared. This is equal to 5 to the power of 3 times 2, which is equal to 5 to the power of 6. Next is the zero power. Anything raised to the power of 0 will always be equal to 1. 5 to the 0, that's going to be 1. X to the 0, that's also going to be 1. B squared C D cubed, everything in bracket to the power of 0 is also equal to 1, regardless of what's inside the bracket. Last is the negative power. A to the negative n is equal to the reciprocal of a to the power of n. For example, 5 to the negative 3 would be equal to 1 over 5 cubed. We're now going to work through some examples to see how we can apply these index laws. The first question we've got a cubed b squared times a to the 4 b to the power of 5. First step, we need to identify the common basis. We've got a cubed times a to the 4. We also have b squared times b to the power of 5. Since they're being multiplied together, all we need to do is add their indices. We're going to get a to the power of 3 plus 4. B to the power of 2 plus 5, and this is equal to a to the 7, b to the power of 7. The next one, we have ab squared c cubed times bcd squared e. Same process. First, identify the common basis. We've got b squared times b. We also have c cubed times c. And then we're going to start multiplying them. There's nothing to multiply with the a, so we just get a as is. B squared times b is the same as b squared times b to the 1. So we're going to get b to have 2 plus 1. C cubed times c is the same as c to have 3 plus 1. And then d squared stays the same, and so does e as well. And this will evaluate to a b cubed c to the 4 d squared e. The next example, we have got division. Same process, identify the common basis. We've got a cubed being divided by a squared, and we've got b to the 4 being divided by b. And because we're dividing them, we subtract the indices. So we're going to get a to the power of 3 minus 2, b to the power of 4 minus 1. This is a b cubed. And in the last example, instead of using the division sign, we now have the fraction bar. But the fraction bar is exactly the same as dividing. So we're going to start with the same process, identify the common basis. We've got the a to the 5 divided by a. We also have b to the 4 divided by b squared. We also have c to the 6 divided by c squared. And so we're going to get a to the 5 minus 1, b to the 4 minus 2, c to the 6 minus 2, and all of this over d. And this would simplify to a to the 4, b squared, c to the 4, all over d. In this next set, we're going to look at how to apply power of power as well as the zero index. The first question, we've got a squared b cubed c all to the power of 0. What we have to do is we simply multiply the power of 4 to every single power inside the bracket. C has got the power of 1. Note that it's not 0 because anything to the 0 would otherwise have been 1. This would equate to a to the power of 2 times 4, b to the power of 3 times 4, and c to the power of 1 times 4, which is equal to a to the 8, b to the 12, and c to the power of 4. The next example, we've got 3a to the power of 0. This time the power of 0 applies to the a only. So this is going to be equal to 3 times 1, which is simply just 3. In the next one, we've got 3a, this time all in bracket raised to the power of 0. So we don't care what's inside the bracket, it's simply just going to evaluate to 1. The next one, we've got 3a, and BC is inside the bracket raised to the power of 0. So only this section is equal to 1. So we've got 3a times 1, which evaluates to just 3a. Let's now look at some harder examples. We've got 3a squared b cubed times, or in bracket 2a squared b to the power of 4. First, we're going to simplify what's inside the bracket. The power of 4 will get multiplied to every single term inside the bracket. This will become 3a squared b cubed times 2 to the 4, a to the power of 2 times 4, and b to the power of 1 times 4. This is equal to 3a squared b cubed times 16, a to the 8, b to the 4. Our next step now is to multiply these new terms together. 3 times 16 is going to give us 48. A squared times a to the 8, that's a to the power of 2 plus 8. B cubed times b to the power of 4 is b to the power of 3 plus 4. And all of this evaluates to 48, a to the 10, b to the power of 7. Here's another example, 2ab cubed times 4a squared c cubed e all over 6a to the 4b squared c e to the power of 4. We're going to start off by simplifying the numerator. We'll multiply 2ab cubed and 4a squared c cubed e together. 2 times 4 is going to give us 8. A times a squared is a to the 1 plus 2. We have b cubed, c cubed, and e. And on the denominator, we have 6a to the 4, b squared, c, e to the power of 4. Let's rewrite this as 8a cubed, b cubed, c cubed, e all over 6, a to the 4, b squared, c, e to the power of 4. The 8 and the 6 can simplify to 4 over 3. And now we're going to group each of the terms with the same basis. We've got the a cubed over a to the 4. We also have b cubed divided by b squared. We also have c cubed divided by c. And the last one, e divided by e to the power of 4. So we're going to get 4 over 3 times a to the power of 3 minus 4, b to the power of 3 minus 2, c to the power of 3 minus 1, e to the power of 1 minus 4. This is going to give us 4 over 3, a to the negative 1, b, c squared, e to the negative 3. Now recall our index law is that a to the negative n is equal to 1 over a to the power of n. So we're going to apply the index law to a to the negative 1 term and e to the negative 3 term. This will give us 4 over 3 times 1 over a times bc squared times 1 over e cubed. And putting this together as a single fraction, we'll get 4bc squared 3a e cubed. In this next example, we've got m squared np times, or in bracket, negative 2m squared n to the power of 3 all over 4 in bracket mnp squared squared. The first step, we need to expand the bracket, and what we're going to do is we're going to multiply the power to every single term inside the bracket for both the top and the bottom. The top will then become m squared np times, now be careful, we've got a negative 2, so we're raising negative 2 to the power of 3. We've got m to the power of 2 times 3, n to the power of 1 times 3 on our numerator. And on the denominator, we've got 4, m to the power of 1 times 2, n to the power of 1 times 2, and p to the power of 2 times 2. Let's simplify this first. That's m squared np times negative 8 m to the 6th n cubed all over 4 m squared n squared p to the power of 4. The numerator becomes negative 8. So we can see again here that we've got m squared times m to the 6th. So we just need to add the indices. M to the power of 2 plus 6. We also have got n times n cubed. Again, we just need to add the indices. N to the power of 1 plus 3. And then p. On the bottom, 4m squared n squared p to the 4. This will give us negative 8 m to the 8 n to the 4 p over 4m squared n squared p to the power of 4. And then simplify. Negative 8 and 4 reduces to negative 2 over 1. Then we pair it. M to the 8 over m squared, n to the 4 divided by n squared, and the last one, p divided by p to the 4. This will give us negative 2, m to the 8 minus 2, n to the 4 minus 2, p to 1 minus 4, which is minus 2 m to the 6, n squared p to the negative 3, which is the same as minus 2 m to the 6, n squared all over p cubed. In this example, we also incorporate some zero power. We've got 7a to the 0, b squared times a cubed, in bracket bc to the power 4, all to the power of 0. First, we can see that a to the 0 is going to be equal to 1, and bc to the 4 all to the 0 is going to be equal to 1. So straight away, we can reduce this to 7b squared times a cubed, which simplifies to just 7a cubed b squared. In this last example, we've got all laws combined together. Let's start off by simplifying each term individually. The first, we've got 3x to the 0 y squared z cubed all to the power of 2. We see that x to the power of 0 is going to equate to 1. So what we have is 3y squared z cubed all to the power of 2. We apply power of a power index law, which means that the power of 2 will multiply to each individual power inside the bracket. This will give us 3 squared y to the power of 2 times 2, z to the power of 3 times 2. The second term, minus 2x to the 0 y squared, well, x to the power of 0 is going to be equal to 1. So it becomes minus 2y squared. And in the last term, minus 3xy to the 0 all squared, y to the 0 is equal to 1. So this is the same as dividing by negative 3x in bracket squared. Now, applying the power of a power to minus 3x, what's going to happen is the power of 2 applies to the entire minus 3 term as well as to the x term. So this is going to be dividing by minus 3 to the power of 2 x squared. Let's tidy this up a little bit. 3 squared, we're going to get 9y to the 4 z to the 6 multiply to negative 2y squared, and we're dividing by 9 x squared. The first two terms will become negative 18. We're multiplying the 9 and the negative 2 together. Y to the 4 times y squared, we're going to add the indices together. And that's going to give us y to the power of 6 and z to the power of 6 stays the same. Dividing by 9x squared still. So putting it as a fraction, we have minus 18 y to the 6 z to the 6 divided by 9x squared. And in the last step, the only thing we can simplify is the negative 18 over 9. That will reduce to negative 2 over 1. And our final answer would become minus 2y to the 6 z to the 6 all over x squared. Thank you everyone for watching the video up to this point. I hope that you did find it useful and that you did learn something from it. If you did like it, please help us by clicking like and subscribe. And if you have any friends who you feel may benefit from this video, please help us also by sharing it with them. We'll be making more of these videos, so stay tuned and we'll see you all in the next one. Bye for now.